Hola, Mr. Sutton here with the Pre-Cal Honors 7-1 Extra Practice Number 3 solutions on graphing conic sections. On this problem, looks like we are graphing a hyperbola because of the minus and the 1 here. So let's start by getting the center. That's going to be 0, 0. And then the x radius, that's the square root of whatever's under the x value there. So square root of 4 gives us 2. And then for the y radius, we have an invisible 1 under this y squared, so square root of 1 is also 1. Now let's go ahead and draw the center and the box from all this. So we have a center at 0, 0, and we're going left 2 and right 2, and then we're doing up 1 and down 1. These are the midpoints of our box. And through the corners of that box, we draw the asymptotes. So there's 1, there's another 1. Now we have a positive y squared. That tells us that we have a hyperbola with up-down branches. So we have a branch up here and also another branch down there. On this problem, this is in standard circle form, so that's what we're going to graph. We have a center at 1, negative 1. Radius is the square root of the number over here, so square root of 25 is 5. So we have our center at 1, negative 1. There's that. And I'm going to make my grid lines actually go by 2s. That's a good idea. So we'll go right there then for the center. So we're going up 5, right 5, down 5, and left 5, giving us this circle here. Based off of the plus here and the 1 over here, it looks like on this one we have an ellipse. So the center for that is going to be negative 1, 0. The left-right radius, the x radius, is going to be the square root of the invisible 1 that's under the x squared stuff there. So that's 1 for our left-right radius. And then for the y radius, we have the square root of 49, which gives us 7. I'm going to make my grid lines go by 2s here. And now my center, we're at negative 1, 0. That's right about there. And we're going left 1, right 1. So very tiny amount of movement in those directions. But now we're going up 7 and down 7. So this is a very skinny vertical kind of ellipse. And let's just draw that out. So there we are. For this problem, the plus here and the 1 tells me I'm graphing an ellipse. We have a center of negative 1, 0. X radius, that's the square root of the stuff under x squared, so square root of 9, which is going to give us 3. And then the y radius is the square root of this 49, so 7. We're going to do 2s for grid lines on this. Our center is at negative 1, 0, so right there. We're going left 3, right 3, and then up 7 and down 7, and there's our ellipse. For this problem, I've got something squared minus something else squared. This minus in here is telling me that I've got a hyperbola. So let me start by getting the center. We've got, for the x value, notice that the x comes second in this particular one. So this is a 3 for the x and a 2 for the y of the center, so 3, 2. Now for the x radius, I'm square rooting the stuff under the x squared, so square root of 9 gives me 3. For the y radius, I've got the square root of this 4 down here, so that's square root of 4, which is 2. Let me graph all this. Now before I graph this, let me check my scale. If I'm over at 3, 2, and I go left 3 and right 3, that right 3 is going to bring me off my grid. So let me make my scale so that my grid lines go by 2s. Now I can fit everything I need. Let's do our center now. We're at 3, 2. That's right here. And I'm going left 3 and right 3, and that fits comfortably on my grid. And now I'm also going up 2 and down 2. Let's draw my box. And here's the asymptotes going through the corners each direction. Now, if you look at the original, we have a positive y squared for this hyperbola. That means that this is an up-down hyperbola. So we've got a branch up here, like so. And our other branch is going to be down below. And there you have it. For this problem, we have an ellipse, because I see a plus here and a 1 over there. Center is negative 1, negative 3. And then the x radius, that's the square root of whatever's under x squared, so square root of 25 is going to be 5. And then for y radius, square root of 16 down there is going to give us 4. We'll make our grid lines go by 2s. So our center, we have negative 1, negative 3 right there. And then we're going 5 to the left, 5 to the right, and then 4 up and 4 down. And there's the ellipse. Connect the dots. For this problem, the square root here is telling us we've got a semicircle. Let's make it look like a circle, and then we can just graph half of it. So I'll do that by squaring both sides. I get x squared equals, and then the negative is gone. We just have 16 minus y plus 5 squared. Add the y plus 5 to the other side, and now we have something that we can graph just like a circle. So we have a center of, well, these x's and y's are actually in the wrong order. So we have 0 for the x value and negative 5 for the y value. And then radius is going to be the square root of 16, so that's going to be 4. The square root is negative over here. X equals a negative square root. That tells us that we are graphing the left half of the circle. The x tells us it's a left-right kind of deal. The negative tells us which one. So let me graph my center, and let me make my grid lines go by 2s. I'm definitely not going to have enough room otherwise. So our center, we have 0, negative 5 down here. And we're graphing the left half of the circle. So let me do 4 up right there, 4 to the left, and then 4 down, and then just graph the left half there. For this problem, I have something squared plus something squared equals 1 with some different fractions. So this is an ellipse. So I need my center for this thing, which is going to be 1, negative 1. And for my x radius, that's the square root of 4, which is 2. For the y radius, I'm square rooting the stuff under y squared. Square root of 36 is going to give me 6. And that's going to be off grid no matter how I graph this thing. So I'm going to need to go with a scale of 2 for my grid lines. So now let's draw all this out. We've got 1, negative 1 for the center. So over 1, down 1. And then I'm going left, right by 2. So 2 to the left, 2 to the right. And we're going up, down by 6. That's my y radius. So here is up 6. Let's see, there's 2, 4, 6 right there. And we're going down 2, 4, 6. There we go. And now connect that to make an ellipse. On this problem, the minus and the 1 is telling me we have a hyperbola. Our center is going to be 0, 0. And then for the x radius, that's the square root of whatever's under x squared. So square root of 16 is 4. The y radius is square root of 25, so that's 5. And let me make these go by 2s, these grid lines, just so I can fit everything. So there's our center. And for the box, we're going left 2, or left 4 rather, 2 grid lines though. Right 4. And then for the up down, we're going up 5 and down 5. And then just draw a box with those points as the centers, or the midpoints of the sides. Now we draw an asymptote through each corner of this box, and that's going to guide our hyperbola. Is it left, right, or up, down, though? Well, I notice we have a positive x squared. That tells us it's going to be a left, right hyperbola. So we have a left branch over here, and then we have a right branch over here.